Greetings to Sevelu and our fellow friends. Today, our group, which is Group 6, will be sharing about elasticity through real-world example that we have researched on, which is electricity. Before we begin, I would like to introduce our group members. Our group members consist of 4 people, which is me, Aididin bin Azmi, Aidi Akasha bin Muhtarmizi, Alif Faika bin Zarimi, and Ahmad Afi Alif bin Ahmad Nazri. Here are a quick overview of electricity industry. As we already know, in our daily life, the electricity industry power almost everything we rely on, from lighting, heating, charging phones, running appliance, keeping business and hospital operational, and many more that we haven't mentioned. Electricity is generated from various sources like fossil fuels, nuclear, and renewable energy, then transmitted over high voltage line to substations, and finally distributed to our homes and workplace. There are 4 types of elasticity. The first one is price elasticity of demands. It measures the degree of responsiveness of the quantity demanded for a particular good with respect to the change in the price. The formula of price elasticity of demand is percentage of change in quantity demanded over percentage of change in price. There are several factors influencing price elasticity of demand of electricity. The first one is nature of good. As we already know, electricity is a necessity in our daily life. So people cannot reduce consumption much even if the price rises, making the demands tend to be inelastic. Next is availability of substitutes. Most families have very little substitute for electricity, making it inelastic in the short run. However, over time, the population is able to shift towards solar power or energy efficient appliance, which will make demand more elastic in the long run. The third one is proportion of income spent. When electricity is relatively cheap compared to income, consumers tend to be less sensitive to prices. At low income level, demand becomes more slightly elastic. Last one is time period. As we already discussed in the second point, in the short run, demand will become less elastic because people are not easily able to change use or appliance. However, in the long run, demand is more elastic as people can switch to energy efficient technology. Here is historical event about elasticity of electricity, which is California energy crisis. It happens due to supply manipulation and demand surge. As you can see, despite high prices, demand dropped only slightly, showing how inelastic electricity was in the short term. To overcome this, the state launched energy conservation campaign, which made demand more elastic over time.
Okay, now we will be looking at the concept of income elasticity of demand, also known as YED. This concept helps us to understand how the quantity of a good that people demand changes when their income changes. In other words, it measures how sensitive consumers are to income changes when it comes to buying a certain product. Here the formula that we use in income elasticity of demand. Percentage change in quantity demanded divided by percentage change in income. Depending on the result, we classify the good based on its elasticity. If YED is negative, the good is an inferior good. This means people buy less of it as their income increases. If YED is 0, the good is income neutral. Income changes don't affect demand. If YED is between 0 and 1, the good is income inelastic. Demand rises with income but less than proportionally. And if YED is greater than 1, the good is inelastic, meaning demand increases more than proportionally as income rises. So now let's apply this idea to real-world example, electricity. Electricity is a great case to study because almost everyone uses it. But how much we use can depend heavily on income levels. As income increases, people typically move into larger homes, buy more electrical appliances and install things like air conditioner. All of this lead to increased electricity consumption. However, even if a household income doubles, their electricity use usually doesn't double. There's a limit to how much more electricity people actually need or can use. That's why electricity is considered income inelastic. YED is positive but less than 1. According to a 2019 study by the International Energy Agency (IEA), in developing countries like India, income elasticity of electricity demand is higher, ranging from 0.9 to 0.8, because access to electricity and appliances is still expanding rapidly. In developed countries like the United States, the range is lower, between 0.2 and 0.4, because most households already have high level of electrification and appliances. Let's look at a quick calculation for both developing and developed economies. In developing economies, a 10% rises in income may lead to a 6% rise in electricity demand, so YED is 0.6. In developed country, the same income rise might only cause a 2% rises in electricity demand, resulting in a lower elasticity of 0.2. This example clearly shows how much income levels and development stage affect electricity consumption differently.
So now let's move to cross-price elasticity of demand. First of all, cross-price elasticity of demand measures the degree of responsiveness of the quantity demanded for a particular good with respect to the change in the price of another good. This definition can be interpreted into this formula, which is percentage change in quantity demanded of good A over percentage change in price of good B. There are three categorical of cross-price elasticity of demand, which is negative cross elasticity, zero cross elasticity, and positive cross elasticity. First, if we have negative cross-price elasticity, where epsilon x is less than zero, it means the two goods are complements. For example, if the price of coffee machines increases and the demand for coffee pots falls, the two are linked, so they are complements. Second, if the cross-price elasticity is zero, or epsilon x is equal to zero, it indicates the goods are independent and they are not related to each other. For example, it might be shoes and orange. A change in the price of orange is unlikely to affect shoe demand. Lastly, positive cross elasticity, which is epsilon x is greater than zero. It means the two goods are substitutes to each other. For example, if the price of Coca-Cola goes up and the demand for Pepsi rise, consumers are switching, which is making them substitutes. We can also applying cross-price elasticity, or we call XED, to electricity, which is our main topic. Electricity itself can be related to several substitute or complementary goods depending on the context. First is substitute goods. These are goods that can replace electricity in certain use. For example, if the price of natural gas is increases, people will find another alternative like electricity, and it will increase the demand of electricity itself. This situation can lead to positive cross-price elasticity. The second is complementary goods. These are goods that are used together with electricity. For example, if the price of electric vehicle is increases, people tend to use more fuel-powered vehicle. Then it will reduce the demand of electricity, which lead to negative cross-price elasticity.
Okay, and now I am going to explain about price of electricity supply. Electricity usually has a lower price elasticity of supply in the short run, aka inelastic supply. Therefore, even if electricity prices rise, the supply generally cannot increase at the same time because of the limitations with the infrastructure such as grid capacity, power plants, and access to fuels. And now I am going to explain about two advantages of inelastic supply of electricity. First is stable infrastructure planning. In order to make electricity, energy providers can generally predict or plan much more steadily because companies know they wouldn't be making any drastic changes to supply in the short run. Second is less risk of overproduction of electricity. They supply inelastic, and therefore changes in supply over short periods of time due to price will not happen. Therefore, there is less waste of resources in the system of unused electricity generation. Next, I'm going to explain two disadvantages of inelastic supply for electricity. First is no immediate response to sudden increased demand. What does it mean is generator cannot respond as quickly as an air conditioner can raise the temperature of their new home. So this lead to supply shortages or blackouts during heat pumps or at peak hours. Second is price increases relative to demand. As supply become inelastic, substantial increases in price often accompany demand increases in a steady supply, leading many producers to pay substantial price increases. And now I am going to explain about factors influencing price elasticity of supply. There are two factors that I'm going to explain, which are ease of entry into the market and level of technology. For ease of entry into the market, what it means is if firms can easily enter the market, supply can increase quickly when prices rise. So it making supply more elastic. Second is level of technology. Advanced technology allows faster and more efficient production, making it easier to respond to price changes. So it will increase the elasticity. And now for a conclusion, electricity demand is inelastic in the short run because consumers have limited ability to reduce usage or switch to another alternatives when prices rise. In the long run, on the other hand, it becomes more elastic because people have time to save energy, such as switch to alternatives like solar or upgrade to efficient appliances so they can better adjust to price changes. So in general, the elasticity for electricity is inelastic, meaning demand doesn't change much when price change.
And this is the list of reference that we are used to complete this research. That's all from us. Thank you for watching.